Welcome to video lesson 11.5 on dividing polynomials. In this section, pretty simple, we're going to learn how to actually divide polynomials. Okay. Yesterday we learned how to multiply and divide rational expressions, and today we'll be learning how to divide a polynomial. So, separated into three different parts. To divide a polynomial by a monomial, okay, then we're going to divide each term of the polynomial by the monomial. All right. So what that means is we could rewrite this as 3x squared, because this is the polynomial, and this is the monomial, okay, because it's just got one term. So we're going to divide it by 3x plus x divided by 3x minus 6 divided by 3x. Okay, so we divided the polynomial into each term, and then we're going to divide each of those terms by the monomial 3x. Now 3x squared divided by 3x is just going to be 1x. Okay, 3's cancel out and one of the x's cancel out. Okay. Now x divided by 3x, the x's will cancel out, so we'll be left with 1 over 3 minus 3 goes into 6 twice. So 2 over x. Okay. And then that is the new polynomial we're left with. All right. Now, example 2 says we could use long division in order to divide a polynomial by a binomial. So now we have a binomial with two terms, okay, and we have a polynomial still, three terms that we're going to divide out. Our first step is to divide the first term of the dividend by the first term of the divisor. So, what we're doing, first term of the dividend by the first term of the divisor. Okay, so we're dividing m into m squared. Okay, and that will be basically m plus 1 will go into m squared plus 4 how many times? And we're going to get an m here, which would give us m squared plus 1m. Okay, then we're going to subtract, and we're going to be left with 3m plus 3. Okay, now what we need to do is divide the first term of 3m plus 3 by the first term of the divisor. Okay, so we're going to divide 3m divided by 3, or 3m divided by m equals 3. Okay, so we have m plus 1 divided by still m squared plus 4. I'm just rewriting what I already have. And then we got m squared plus 1m. Okay, and then we get 3m plus 3. And if we multiply all of this by 3, okay, then we're going to get 3m plus 3 again, and we get a remainder of 0. Okay, so m squared plus 4m plus 3 divided by m plus 1 is really going to be m plus 3. Okay, that's our solution using long division. Now, sometimes when we use long division, we might get a non-zero remainder, so then we have to use this rule. The dividend divided by the divisor equals the quotient, plus then we just write the remainder as a fraction, just like we did if we would have a remainder with regular long division. Then it would be the little fraction part if we didn't want to write it as a decimal, which we can't write this part as a decimal, obviously, when they're dealing with polynomials, so we would just write it as a rational expression, the remainder over whatever the divisor was. Okay, so we'll take a look at example 3. Again, we have a polynomial divided by a monomial. Okay, but this time probably we're not going to get 0 as a remainder. So their dividend is the first expression, and our divisor is the second expression. Now, when I wrote this like this, I noticed, oh, this is not in standard form. It's going to be difficult to divide things if they're not in standard form. So the first thing we need to do, okay, is change that and rewrite the expression so it's in standard form. Okay, so y squared minus 7y plus 2. Now it's in standard form. Okay, and now we're going to see how many times y minus 3 can go into y squared minus 7y. Okay, so we're going to multiply that by y. Okay, and that will be y squared minus 3y. And we'll subtract negative 7y minus negative 3y. Okay, will be negative 4y plus 2. Now our next step is to see how many times y minus 3 will go into negative 4y plus 2. Okay, and that's going to be just 4. Okay, actually, sorry. It'll be a minus 4 in this case because we have this negative 4 here. Okay, so negative 4, and off to the side I can do this, times y minus 3 is going to give me negative 4y plus 12. Okay, and I'm subtracting again. Negative 4y minus negative 4y cancels that out. 2 minus 12 is negative 10. Okay, now my remainder is negative 10. So I'm going to minus 10 over the divisor, which is y minus 3. So my quotient then is y minus 4 minus 10 over y minus 3. Okay, and that is my answer. Okay. Now in example 4, we are going to have to insert a term that's missing. Okay, so you'll notice we don't have like a q term here, so we have 3q squared. Then we can have plus 0q because we don't have it there. So if we multiply it by 0, that's the same as it not being there. Okay, minus 8. And we have to do that so that we can at least divide out. Okay, and our divisor is q minus 2. All right. Now we need to multiply q minus 2 times something so that we can cancel out this 3q squared. So we're going to have to multiply it by 3q. Okay, now 3q times q is 3q squared. 3q times negative 2 is minus 6q. Okay, we're going to subtract them. 0 minus negative 6 is going to be positive 6. Sorry, that's a q minus 8. And now that will go in 3 times. Sorry, 6 times is what we're going to want here. Okay, to give us 6q. Then since that was a 6, it's going to be minus 12. We're going to subtract. Okay, that cancels that out. Negative 8 minus negative 12 is positive 4. So then our remainder, okay, is 4. And now it's plus because it was positive. The last one was minus here because it was a negative 10. That was our remainder. And now since a positive 4, we have plus here. And then we divide by the divisor. Okay, so it's 3q plus 6, okay, plus 4 over q minus 2. All right. Please make sure you write down any questions that you have about dividing polynomials. Okay. The first two are a polynomial by a monomial, so you're just dividing each term by the monomial. The second two, so 3 and 4, you're using long division. Okay. Remember, if you have a remainder, you write the quotient plus the remainder divided by the divisor. Okay. Again, ask your questions tomorrow when you have them. I'll be sure to answer them in class. Thank you and have a great day.